So we're focusing on an important behavior of atoms, and that is how they turn into ions. It turns out that a lot of the bonding that happens in the world to make the stuff that we find in this world requires atoms to turn into ions. So how is it that that happens, or why is it that that happens? Well, for reasons I don't want to get into fully, it turns out that every atom desires one important thing, and that is that its outermost energy level be completely filled to capacity with electrons. And filled to capacity for an outer energy level means 8, with very few exceptions. There are a couple where the outer energy level can't hold 8, but those few elements near the top of the table. But for almost every other element, outer electrons of 8 is what it really desires. So how does that happen? Well, there's one of two ways, and it really comes down to this. If an atom has less than 3 outer electrons to start with, then the easiest way for it to turn into an ion is it will lose all of its outer electrons. And so you might ask, well, wait a minute, how is it going to be full if it loses the outer electrons it's trying to get? Well, that's because these atoms have electrons that are inside of the outer energy level. And so if it completely clears out its outer level, then the next level in is then considered the outermost energy level. Let me show you here with an example from the periodic table. Let's just use cesium. Here's cesium. And the electrons that are in the different energy levels in cesium. There's 6 different levels. So we got 2, 8, 18, 18, 8, and 1. Notice that if I get rid of this 1 right here, if cesium were to give away that last electron, then the outer energy level would be not the 6th, but the 5th level. And it has 8 in it, which is exactly what cesium would want. So all of these ones here in group 1 can just get rid of that last little number, that last little 1 electron, and the next level up then becomes a full outer energy level. That's perfect. And all the ones here next to it in the alkaline earth metals, see they have 2 in the outermost level, that last number. So if they get rid of 2, then they would have a full next energy level in, or outer energy level. And even some over here in the 13th group, they have 3 outer electrons. Now it turns out when you get further down here, again it's getting a little bit involved, they're not very likely to do that, but up here at the top, if I ever ask you, you could say boron, aluminum, gallium, those are the ones that will lose 3. And I realize I should have said less than 4, because even if they have 3, they can still do that, okay? And what if they have more than 4 outer electrons to begin with? So now we're talking about anything above group 14. So in group 15, we've got nitrogen, phosphorus. They have 5 outer electrons. Over here in group 16, we have 6 outer electrons. Well, it's really difficult to give all those away. And so instead, they are going to gain more electrons to make 8. So however many they are short of 8, they're just going to gain that many. So those there in group 15, they have 5 outer electrons. They're going to gain 3 more. If you're over here in group 17, where there's 7 outer electrons, they're going to gain 1 more. Okay? And 2 groups, group 14, those are the ones with exactly 4. It's not very easy to lose 4, nor is it easy to gain 4. They don't form ions. And also group 18. They're already full. And so they don't form ions. All right. So I might ask you sometimes, like, what about metals? Well, metals, you have to know, are generally on the left side of the table where you have very few outer electrons. Those are the ones we will lose electrons. If I ask you about most nonmetals, those are over here on the right side of the table, the ones with a lot of outer electrons. So they're more likely to gain. Okay? So be able to identify where on the table you are, and that will determine whether you're going to be a gainer of electrons or a loser of electrons. Okay? Hope that helps clear that up if you needed it.